Let us begin, friends. In this section, we are going to look at the concept of time value of money. Now, what does come to your mind when you say time value of money? It means money has different values depending on the time that we are referring to. Let us say we are talking of a timeline. So this is 0 time period, and let us say this is 5 year hence. Now let us say at the beginning of the period I have got this 100 units of money. Now depending on what I do with this 100 rupees of money will determine what will be its future over here. Okay, let us say I invest this money at 10% interest rate every year. So its value after 5 years will be depending on how much I am yielding on the investments that I have done. Second is that let us say I don't invest that money anywhere. So if I don't invest that money over into some instruments, the value of that money is going to get deteriorated at the end of 5th year. So whatever I could have purchased with 100 units of money at the beginning of the period, I may not be able to purchase the same thing at the end of 5th year, because due to inflation my purchasing power of money has gone down. And third is that its value at the time period 0, if I make a choice of consuming this, is worth 100 rupees. So you can see the time determines the value of money. At the beginning of the period the value is 100. At the end of the period, if you invest it at 10% interest rates, value will be 100 into 1 plus 10% raised to power 5. If you don't invest that 100 rupees and just keep it in the form of cash, then its value is going to degrade and it will be definitely less than 100 units, which means my purchasing power of rupees 100 got downgraded over a period of time. That is what tells you that time becomes a very crucial factor in terms of determining the time value of money or value of money. Now let us go ahead and see various forms of time value of money. There are two forms predominantly. One is called as present value and second is called as future value. Now future value predominantly determines the value of your current investment in the future. So let us say this is 0 time period and this is end time period. You invested amount A over here. What will be its value at the end of time period N is determined by future value. And what is the value of an amount that you are expecting at the end of nth time period and the beginning of the period is given by present value of money. So let us take some examples. So let us begin with future value of money. Now let us say on the timeline I invest a lump sum value at the beginning of time period. Now I want to identify its future value at the end of nth time period. The equation for same is given by FV is equal to lump sum into in bracket 1 plus R raised to power n. Now what is R? R is the rate at which the money got invested. So the LS gets compounded at R rate every year for n years. Now let us take example. Let us say that we invested 100 rupees for 1 year. So 100 into 1 plus, let us say at 10% interest rate we invested that money for 1 year. So the equation for future value becomes FV is equal to 1 plus R raised to power 1. So the value becomes 110. Now let us say if we invested this 110 once again for one more year. So this is the first year and let us say for second year. Okay, so the future value in that case becomes 110 into in bracket 1 plus 10% raised to power 1. Now if you replace this 110, you can say it is 100 into 1 plus 10% raised to power 1 into 1 plus 10% raised to power 1. So simply said, at the end of 2 years you can say the beginning amount into the interest rate to the power of number of years future you want to look into. Now that becomes our standard equation as we have seen in this case. Now here we looked at the cash flow that is happening only once, and that's why we called it as lump sum. What if the cash flow occurs repeatedly? So let us look at that example of annuity. So let us say that that this is the timeline and these are n number of years. Okay, so I am keeping it little general. So first year, second year, so on up to n years. So every year I am expecting a cash flow A till the end of the time period. So in this case my future value is denoted as future value of annuity and is represented by A into in bracket 1 plus r to power n, where r is the rate at which the annuity is invested every year, minus 1 whole divided by r. So that is how you will give the value of annuity or future value of annuity. Now that happened about future value. Now let us look at the present value. Now in case of present value, reverse is true. Let us say at the end of nth time period, you are expecting a cash flow of ls. So what we want to identify is what will be that cash flow at the beginning of time period. So it is given by PV is equal to lump sum by 1 plus r raised to power, and where r is the discount rate or expected rate of return. So PV is given by this equation. If the cash flow is in the form of annuity as we saw in the earlier case, then the equation becomes little different. So I'm just going to plot this timeline first, and after that we will look at how does the equation get modified. So first, second, third, fourth, fifth, so on up to nth time period, and every year you are expecting a cash flow of A, which is an annuity. So present value of annuity is given by A into in bracket 1 minus 1 upon 1 plus r raised to power n divided by r. Now all these equations, whether it's FEA or PVA, is derived by using the geometric progression, the details of which we are not going to look into this lesson. So this is present value of annuity. Now there are certain other forms of present value which are going to be critical from the perspective of valuation. So let us have a look at them as well. The critical form that we will frequently use is present value of growing annuity. Okay. So now as a part of this present value of growing annuity, what we do is, or what we are expecting is, we are expecting the cash flow will increase every year by a growth rate G. So on up to nth time period. So over here the cash flow that you are expecting is A into in bracket 1 plus G. Over here you are expecting A in bracket 1 plus G square, so on up to here you would expect A in bracket 1 plus G raised to power n. Now present value of growing annuity is given by an equation which is A into in bracket 1 plus G in bracket 1 minus in bracket 1 plus G upon 1 plus R whole raised to power n divided by R minus G. Now that is the equation for present value of growing annuity. Now in case the present value of growing annuity is infinite, what will be its equation? That we will see in the next moment. So let us have a look at it. So before we look at present value of growing annuity, let us look at present value of perpetual annuity. Let us say that you are expecting annuity every year till so, so till the infinite time period. So what we are saying essentially is this annuity is going to be infinite. So in that case, present value of perpetual annuity is given by A divided by R, where R is the discount rate. And let us say this annuity, if it is perpetually growing at growth rate G, which is typically a stable growth rate, then so it is A into 1 plus G, and over here it will be A into 1 plus G square, so on up to infinitely. So in that case, it is called as present value of perpetually growing annuity, and is given by A in bracket 1 plus G divided by R minus G. These are the basic equations that you need to keep in mind before you deal with the valuation aspects of equity analysis, or for that matter anything and everything that relates to discounting of cash flow analysis. So we take a break over here. Meet to you in the next session. Thank you.